We have applied artificial intelligence to detect money laundering activities using information publicly available in companies' register. Money laundering is a process of cleaning funds derived from crimes such as corruption, drug or human trafficking to appear legitimate. Despite the amount of money laundered representing around 3% of the global GDP, money laundering is very hard to detect. The detection of money laundering appears to have similarities with breaking the code of the Enigma machines during World War II through the use of metadata and Bayesian networks. Our database was created by extracting companies' information from the United Kingdom's companies register and labeling 8,000 companies involved in money laundering, part of the Troika laundromat, through a search algorithm, and building a database of 8,000 companies whose activities appear legitimate. We also included metadata information such as the location of the officers.
Hello, my name is Sebastian, and I have implemented our first approach, a reflex-based model, which has as input 8 features: total number of officers, number of active officers, number of inactive officers, number of non-person officers, total number of persons with significant control, number of active persons with significant control, number of seized persons with significant control, number of non-persons with significant control. The reflex-based model uses a deep neural network with 5 hidden, fully connected layers activated by the ReLU function, where layer 1 has 18 units, layer 2 36, layer 3 180, layer 4 36, and layer 5 18. The output layer uses a sigmoid activation to output the probability required by the binary classification. As metrics, we used cross-entropy loss as the loss function and the binary accuracy for evaluation. The model produced the following results. The loss on training set was 0.44 with an accuracy of 0.77. The loss on validation set was 0.46 with an accuracy of 0.76, and the loss on the test set was 0.31 with an accuracy of 0.87. Our first basic model did quite well and achieved a predictive power of 87%, which is quite satisfactory at this stage, but the difference of about 10% between the validation and test set is also a signal that the two data sets may have come from slightly different distributions. Thank you.
For the Bayesian networks, we tried to follow a slightly different approach. First of all, we created a node for each officer or person of significant control that is used to indicate whether they are present in the company or not. Using those nodes, we can then proceed to calculate 2 indicators. The first one is dependent upon their names and is actually the percentage of names that we know have been involved in fraud in the past. The second one is dependent upon the officers or persons with significant control countries. It is actually an indicator which is proportional to the frequency of those countries in the training set. In the figure, those indicators are denoted by OS and PS for the names and OCS and PCS for the countries. Using those nodes and the mean debt to equity ratio and the mean turnover to equity ratio, we can then proceed to calculate the probability of fraud for each company. We also use a discretization function in order to make our life easier and avoid having to deal with continuous probability distributions. The accuracy in the case of neural networks was equal to 87%, which suggests that the model itself generalized very well. But in the case of Bayesian networks, we observed extreme overfitting. We will try to improve the Bayesian network based on what we observed in the first case, the case of the neural networks. What we'd like to showcase with our research is that the combination of financial data together with metadata about the company can help build strong models for fraud estimation. We will obviously try to improve our model by using data from other countries and actually use that data to see how our model performs there. Overall, we feel there is much potential in our research and we'd like to pursue it even further and realize its true potential.